So this is normal distribution, and I don't have a whiteboard, so I made this nice color-coded curve. So this is called a normal curve, and it just like breaks down percentages. And within this normal curve, there is 3 standard deviations to the left and 3 standard deviations to the right. And in the middle is the mean, meaning the averages. And so the averages percentages that you'll see like are 68%, 95%, and 99.7%, which is like the averages for the curve. Okay, and then dividing like this in half would be 34 and 34, and then you keep dividing it. It's 13.5, 13.5, 2.35, 2.5, and then 0.15 and 0.15. And so if you want to use this in a real life example, you would say, here's an example. Say you have the height of adult American men are normally distributed with a mean of 76 inches and a standard deviation of 4 inches. And so first you have to lay this out according to what you're given. So you're given the mean, which is 76. So you put that in the middle. And then you would add 4 on each, like you add 4 up and then you subtract 4 down because it's going negative standard deviation and it's going positive. And so you get 80, 84, 88, 72, 68, and 64. And say you get a question like, what percent of American men are between 72 inches and 80 inches? This is this section right here, and that is 68% because it's just this section. But if it was the yellow section and the green section, it would be 95%. And then if it was everything, like, or say it was blue, it would be 99.7%. If it was everything, it would be 100%. Or if you want to know what percent of men are taller than 80 inches, you would just add what is right here because you're going what is more than 80 inches. So you'd add 13.5, 2.25, and 0.15. It's really simple when you like get to know the curve. You just have to study the curve and understand this. And that's basically it. So yeah. And one more thing, the percentages help us predict, like, well, in this case, it can help us predict, like, what height an adult male would be, because, like, this is just average, like, what is normally out there. So it helps us predict things, and, like, it helps with statistics and stuff. So this curve can help with, like, things that people want to find out, like, what, like, how many animals eat this, or, like, just anything like that. Like, it's super easy. So this is, dot plots, box plots, and histograms. Not Instagram, histograms. That's what I meant. So, what if 30 students were asked to report the number of TVs in their household? Okay? And then you have a table to give their responses. So I will show you that table. This is the table, and these are the students' responses. Yes, there's 30 of them. And this thing is asking me to create a dot plot. So, you put all the numbers that are here, like once, on the bottom, your x-axis, or whatever, just this bottom, and like one of each. So 0, 1, 2, 3, 4, 5, 6, 7. All the numbers that appear here. And you record each one. So you're just recording data. It's really simple. You put a dot for every one you see, every 2, every 3, every 0, all of that. And once you're done with that, you have this beautiful shape. It looks like a city, almost. And this shape is called a skewed right. Well, unimodal skewed right, because there's only one bump, and there's only one bump skewed to the right. So unimodal skewed right, okay? And so this is the number of TVs in household. It's like a data. And then you create a box plot. So your, what's it called? Your minimum is 0, and your maximum is 7. And you call, your medium is 2. So the middle of your box would start. That's where your box is. Like, that's the middle of your box where it's divided is 2. And then since your Q1 is 1 and your Q3 is 3, you would just extend the box to that. And it's that simple. That's your box plot. So that's your dot plot, and that's your box plot. And then you would create a histogram, which is also a fancy word for a box. I mean, for a, what's it called? Bar graph. And so this is your frequency, like how frequent or whatever. And this is the TVs. So you would graph it. And it's like that simple. Your frequency, like how frequent does a number show up less than 2 to 0? Or how frequent does a number show up less than 4 to 2? How frequent does a number show up from less than 6 to 4? And how frequent does a number show up from less than 8 to 6? And you count, and then you just graph it. And so this is TVs to frequency. And then you can use your calculator to easily solve the statistics. Calculator, I've entered all the data from here into list 1, which is from stat. So now all I have to do is press stat, calc, and then var stats, and then press enter. And it gives me everything I need to know for this question. This question is asking for the mean, standard deviation, and 5-number summary, and the median. So the mean is 2.53, the one with the x. The standard deviation is the one with the little o and x, which is 1.5. And then the median is 2. And the 5-number summary is right here, 0, 1, 2, 3, 7. what magic can calculators do? It's great. And then, okay, the IQR is Q3 minus Q1. And Q3 is right here, and Q1's right here. So 3 minus 1, and you get 2. And then for the last one, it's saying describe the distribution. And we already know that from this dot plot, it is a unimodal skewed right. And the median is 2, and IQR is 2. So that's like the standard deviation. And so that's it. All you need is calculator and graphing skills, and you could do this problem super easy. So that is your dot plots, box plots, and histograms. This is my example of how a crazy girlfriend would act. Because, you know, I want to be an actress, so this is just my coming out. It's like the come up. So just watch.
Oh my God, don't ever leave me.
Ever.
Good. Because I'd find you.
Okay, so now this is relative frequency tables and more Instagrams. Just kidding, histograms. Histograms. Okay, so like last time it was 30 students counting TVs in their household. Now it's 30 students in PE class ran one lap around the track, and then their times are recorded in seconds. So let me show you these times. So these are the 30 times of students running in a PE class, like one lap. Dang, someone ran a 61 seconds. That's a minute lap. That's pretty good. Well, anyway, so the first question asked me to make a relative frequency table using intervals of width 10 and starting at 40. So my beautiful table right here, I started at 40 and I used intervals of 10. So I made a frequency table. How frequent did a student run less than 50 seconds to 40 seconds? And I only got 1. And how frequent did a student run less than 60 seconds to 50 seconds? And I only got 3. And so on. Then I took the number out of 30, which was, so only one student ran less than 50 to 40. So I put 1 out of 30. And then I divided it and made decimals. So that's what I did for each one. So that was the frequency table. So next it wants me to draw the relative frequency histogram. So I did that in my graph, and I used my data from here. And so the y-axis is the relative frequency, how frequent a person ran a certain thing. And then this is my x-axis, which is like the intervals, like from less than 50 to 40 and all of that. And so I graphed it, and then this is how it looks. So this is the histogram. And then C is asking us to calculate descriptive statistics and use them to describe center, spread, and shape of the distribution. So you do this with your calculator again. So I entered all of the things, all of the data, and you press stat, and then you go to calc, and then you go to var sets. And look, all beautiful right out for me. My mean is 76.2, you see? And then my median is down here, which is 75.5, okay? And then my standard deviation is 13.8, right there. It's a little off, but basically. And then this is a symmetric data because look, it's like this. It's like shaped like a bell curve almost. And then it's unimodal because there's one hump, and then the center is the mean because it's symmetric. But if it wasn't symmetric, it would be the median. And then the spread is just the standard deviation because it's symmetric, so it's also 13.8. So what percent of observations lie, or calculate the interval that contains values within one standard deviation. So in order to do that, all you do is you take the mean and you subtract your standard deviation of 1, which is 13.8, and you get 62.3 for the negative one. And then to the left, and then to the right would be 76.1 plus 13.8, and you get 89.9. And then to calculate the percent, you would just divide 20 divided by 30, and you get 67, which is approximately close to 68, which remember is the average. The average for one standard deviation, so it's close. Then F is just asking the same thing, but with 2 standard deviations. And so to do that, you just subtract 1 standard deviation, but times it by 2, and you get 48.5. And then for the right side, you just add 2 times 13.8, and you get 103.7. And then to calculate that, you just divide 29 divided by 30, and that's 0.966, which is about 97%. So the question number H, or letter H, is saying, do you consider the distribution to be approximately normal? If not, how does it differ? It does not differ. It is approximately normal, and the percents are close to the expected, which is the 68% and 97%. So that's it. It's really simple once you get the hang of it. You just kind of know how to graph and know your standard deviation and know how your bell curve works. And that's it. That's done. Relative frequency tables and histograms. Last life lesson. This is so sad. But, you know, it's okay. Move on. Life moves on, but I'm going to miss it. But, okay. So in high school, it's asking me if I met my goals, did I have any goals, and what helped me meet my goals and what prevented me from meeting my goals. What did I learn from my life and I can take with me in the future. Okay, so I did meet some goals, like, you know, grades and sports. I had goals, yeah. I wanted to do better in sports this year. I got on JV soccer. I mean, it's like whatever, it's JV. It's like not that big a deal. And then, but I got on varsity track, and so I was happy about that. And I made it to CIF and stuff. And I got a 4.0, which I wanted to get, and hopefully I get over 4.0 this semester. And what helped me meet my goals was just constantly staying positive. Like, you have to stay positive and focused, you know? And I had my friends with me to help me and support me and my family and stuff, and just a good environment. And I may have got distracted with, like, boys and stuff, stupid stuff, but I stayed on track this time. Like, on track. Haha, that's a pun. Okay, maybe it's not. But I stayed on track. Like, I tried to focus and look at the good side of everything, good side of life, because there's always going to be bad in life. But I looked at the good side of things, because if you don't look at the good side of things, you'll never have anything to hold on to. You just have to look at what's left that's good, not the bad. So you can't let the bad consume you, kind of thing. And so that's what I can take with my future, is that you have to stay positive no matter what, because nothing is forever, the good and the bad. So that's how that goes. So life gives you lemons, you make lemonade. Basically, that's what I'm trying to say, I guess. So that was my last life lesson, and I hope you enjoyed my video.